Hi, everyone. In my last two posts, I explained how AI technology is basically models that have been trained on lots of data so that they learn the general statistical relationships between inputs and outputs in some domain and can then be used to make predictions of reasonable outputs based on new inputs fed into the model. That's the setup. Of course, there's a huge amount of complexity behind the scenes, as you might imagine, but this basic configuration powers models that can do amazing things. But how do they generate new content, like poems or images, based on some input prompt, as we see with ChatGPT, DALL-E, Google Bard, for example? Today, I'll start to describe how that works, again, in a very simple, high-level way, with the hope of just giving curious folks some kind of basic intuition about it. Now let's talk about a language model, which is where a lot of the big advances in AI research have been happening in recent years. Consider a model that predicts the next word in a sentence, given the sentence so far and the topic. And this is, in fact, exactly how ChatGPT and the other models work today. Models have been trained on lots and lots of actual sentences, probably taken from the web, because the web is huge and easy to access. Now, the basic patterns it has learned help it to know what a grammatically acceptable and reasonable next word would be. Again, the model doesn't understand what's being written in any sense other than the patterns of what words tend to follow what other words in works written by humans in the context of a given topic. So, with all the training it has done, and with the zillions of internal weights that capture those sophisticated statistical relationships between words, the model can now predict an appropriate next word. That new word is added to the sentence fragment, and then the whole new fragment is fed back into the model to get the next word, and the next, and so on and so on. That adding on a word and feeding the longer fragment back into the model is kind of interesting. The next word is the unknown, and gets predicted as the output of the model. But as soon as the model has made a choice, that word is now part of what is known and becomes input to the model to get the next word. I think there's some philosophical thought in there about how our choices, once made, create reality, but I'll leave exploring that to some other time. Now, in reality, of course, as you speak or write a sentence, there are usually many words that could be the next word and still be correct. Depending on where you are in the sentence, you might be constrained to a very small set of words that could work in that exact spot, or you might have lots of options. For example, you might say lots or a bunch or zillions fairly interchangeably. In practice, our AI model doesn't just predict one next word. These language models predict a whole set of possible next words, each one having a probability attached to it of how likely that particular word is to be the next one. Then the model just randomly chooses among those possible next words. Yes, randomly. It does probability weighted choice so that higher probability words are more likely to get chosen, but a lower probability word might get chosen. In this way, a truly novel sentence is generated with a certain amount of random choices that still fit with what the model understands to be correct and pertinent. For this reason, you could ask the model the exact same question twice and get two different, but still both reasonable responses. Not only might it use different synonyms, as in the example of lots versus a bunch versus zillions, but let's say, for example, you enter a prompt about a tractor. The model produces a sentence fragment, and then along came a tractor. If you did not specify any specific characteristics about the tractor, the model might also say, along came a red tractor, or along came a big tractor, or along came an old tractor. Since these are all grammatically correct and not in conflict with the prompt, which didn't specify any characteristics, the red, the big, the old is being added in randomly, but their inclusion gives the impression of creativity on the part of the model. So you see how sentences can be generated by randomly choosing the next word from a set of words that the model has learned would work in that spot, and doing that over and over again until you have an essay, for example. Now, imagine that words in a sentence could be thought of as any kind of sequence, such as what musical note might come next in a song, given the song so far, and perhaps the style of music as an input prompt. The same basic idea works. Or let words be colors of pixels in an image. These large language models that are at the cutting edge today were motivated originally by trying to do better translation of text between different human languages. But researchers have discovered that the models can actually be used in a variety of domains beyond language. They can be mapped to other kinds of use cases, and they still work. So hopefully today you see how a simple model construct can create entirely new sentences or whatever sequences you want potentially, but still be completely based on the things it's learned. And this is important to keep in mind. It is regurgitating memory just in new ways, with random decisions being thrown in about which memory to regurgitate at each point. The magic of the model is in the learning, how the model gleans those patterns of what words are likely to follow other words in given contexts by looking at lots and lots of training data sentences and having its internal weights nudged into the right directions to capture those patterns, as we talked about last time. So thanks, everyone. That's my thought for this time. I'll be back again soon with more. Take care.